So let's now look at what yeast are actually doing, or the stages that they go through as they ferment the wort into our beer. And so of the topics here, only the first three we could say are actually the fermentation phases: the lag phase, exponential phase, and the stationary phase. And then we'll go over a little bit about concepts and measurements related to attenuation, and then the conditioning that we can do. So if we're looking at the fermentation phases, what's called the lag phase is what occurs shortly after pitching the yeast into the wort. And so during this time, the yeast aren't really growing yet, they're just gearing up. Then they're not reproducing actively. So they're taking in oxygen that is hopefully there. They are synthesizing and taking in amino acids, minerals from the wort, and vitamins. And so of these, the oxygen is very critical because it's needed to synthesize sterols. And sterols are important for the yeast to provide adequate pliability to their cell membranes. And so it's important to ensure that oxygen is available and is adequate, because when you boil the wort, it removes basically all the oxygen from it. And so it needs to be aerated before the yeast are added. And so during this time in the lag phase, the yeast are beginning to build their proteins in the cell and to synthesize the enzymes. So they start to express their genes into the important enzymes and the important transport proteins that are necessary to continue this process. And then from about 4 hours, from as soon as 4 hours to lasting until maybe 4 or more days after pitching the yeast, we have the exponential phase. And this is when the yeast population is actively reproducing. And so with each generation time, the time it takes for one generation, the population of yeast is doubling. And that's why it's called exponential growth phase. So as they're reproducing, they're eating up all the sugars in the wort, and they're producing the carbon dioxide and ethanol through their main way of metabolism, which is the fermentation. And so there's a lot of carbon dioxide that's produced in this foam, along with other yeast cells and other pieces from the yeast or from the wort make up the krausen, and that is what initially makes that big foam at the top of the fermenter. And so let's look at the order of sugars that are used by yeast. So the first thing they're going to want to use is the glucose. This is the smallest and simplest sugar, and so they can import that and feed it straight into the glycolysis process, and so that's used first. Next is fructose. Fructose is also a simple or monosaccharide, and that can be readily modified into a compound, phosphorylated into a compound that also goes straight into glycolysis. And then next, sucrose would be taken in. So sucrose, which is also table sugar, is a disaccharide, and so that has to be cleaved by the enzyme sucrase. But then the single sugars that come from it go into glycolysis, and then is when the maltose gets utilized. And maltose is in most worts is the most abundant type of sugar, but because it's a little more takes a few extra steps to be used. It is not utilized first. So when the maltose is utilized, the enzyme maltase will split it into glucose units in the cell. It also has to be imported, and so the maltose permease enzyme or transport protein is what brings that in. And then last to be utilized is maltotriose. And in fact, some strains don't utilize it at all. And partly this is determined by how well it's utilized is determined by how much flocculation the yeast strain has. With lower flocculating strains will be able to consume the maltotriose more because they stick around dispersed in the fermenting beer longer, and so they'll provide more maltotriose utilization and overall greater amount of attenuation. And then when things slow down, the yeast go into stationary phase. And so the time that it begins can vary from 3 days all the way out maybe to 10 days after pitching. And this is when the yeast become inactive. And so at this point, they've used up most of the, or all the available sugars that they can. Ethanol has accumulated to the point that it begins to inhibit their metabolism, and so they just become dormant. In the early part of the stationary phase, though, the beer is still green. Their compounds that affect flavor, many of them have been produced, but the proper balance may not be achieved, and partly it could be that we have too much diacetyl or sulfides remaining. So as the fermentation, or I'm sorry, as the stationary phase continues on, the yeast will reabsorb the diacetyl and as well as acetaldehydes, and the sulfides will continue to off gas. And at this time, the flocks of yeast will go, if they had been floating at the top, they'll begin now to settle to the bottom of the fermenter. So at this point, it's important that the brewer needs to have a good monitoring of the attenuation, the specific gravity that's here in the beer now, before assuming that the fermentation is just complete and then crashing the temperature. If you have too much sugar remaining and things have slowed but not have gone too far, then you also may leave too many off flavors. And in some cases, you may even need to rouse the yeast or pitch additional yeast, or sometimes help things along by raising the temperature. So speaking then of attenuation, it's important to understand and be able to measure this. So attenuation is just the measure of how much or how completely the yeast have used up all the fermented or fermentable sugars in the wort. And we show this as a percentage. So what is done is you compare the specific gravity measurements of the original gravity before pitching and at any time now after fermentation. And so the measurement of what's called apparent attenuation is basically just a measurement of how close the specific gravity the final gravity is to 1.0, which would indicate that all the sugars have been consumed. Because, as you'll have probably learned, the sugars in the wort increase its density, its specific gravity. And so you may have a specific gravity original of 1.060, and then you would use this formula to determine the apparent attenuation by subtracting the final gravity from that, and then dividing it by just the original gravity minus 1, which, like in that example, would be 0.06. And then multiply that by 100 to get the percentage. So one needs to be aware of what the expected attenuation range is for the strain of yeast that they're using, because it can vary. And then with that range, then the attributes of the wort and other fermentation conditions can make the attenuation range vary. But you want your attenuation to get into that range, and so it's important to, as fermentation slows down into stationary phase, to continue to check the specific gravity to see if the fermentation is complete enough. And it's important to collect that data on every batch of beer that's made, what the final gravity is when the fermentation is ended, and that can help to improve quality from subsequent batches. And then part of extending that that stationary phase, or what's important to continue, is to allow for a diacetyl rest. And so this is after fermentation is slowed down to give yeast additional time to reabsorb the diacetyl. So they may not have had a chance to clean up after themselves and reabsorb that if the temperature is crashed too early. So this can also and so what you would usually do is it's important to do taste tests to see if you can detect the butter diacetyl taste or the slick mouthfeel, and if so, give the diacetyl rest longer to occur. However, there may be undetectable acetolactate, which is the precursor of diacetyl, still in the beer, and then after the yeast have been crashed and removed, if this oxidizes, it'll turn into diacetyl then, and it can't be easily removed with more time at that point, because it's the yeast that have to reabsorb the diacetyl. And so one can evaluate this with a force test. This is described in the yeast book, page 223. But essentially you just take 2 glasses of beer and cover them, and one you put in a water bath at an elevated temperature alongside the other one that is just left at room temperature. And that's the force test. And so if the higher temperature one develops more of a diacetyl taste, then it tells you that there's additional acetolactate in the beer still that is able to convert into diacetyl if the temperature's right for that. And so it's also important to allow the diacetyl rest to occur. Many times you'll want to elevate the temperature higher than what the fermentation temperature was, which will allow greater reduction of diacetyl, especially if you're looking at lagers, which are fermented at very low temperatures. So considerations on that and temperature control for the diacetyl rest can be seen in the yeast, page 112 to 113. A lot of brewers will want to perform bottle conditioning or cask conditioning to carbonate the beer. And this has a side benefit in that any oxygen that's remaining in the beer when it's put into the bottle can get removed by the yeast activity to do that little bit of extra fermentation. However, it does carry some risks for the brewer, and part of this is that it's may be a little bit difficult to control or have consistent results from bottle conditioning. And the death of the yeast that are remaining in the beer after and during and after bottle conditioning can result in destruction of the yeast cells through autolysis. And that breakage can lead to leaking of other flavor-active compounds that you may not want. And then some people don't want to do bottle conditioning because if they're selling the beer, they may be afraid that some consumers don't like the appearance of a little bit of yeast at the bottom of the bottle, or they may not understand it. And so the best approach is to use the smallest amount of yeast possible to give the carbonation that you're looking for. So if you're not filtering your beer, then even after flocculation, the unfiltered beer probably has enough yeast in order to bottle condition, and you can just add a little bit of additional sugar. You do want at least, or about 1 million, not at least, but about 1 million cells per milliliter of beer. If you have a higher gravity of beer, then you may need additional yeast in order to properly condition that. And for that conditioning, it's better to use the simple sugars such as sucrose or glucose or maybe fructose, because the maltose, if it's added, may not ferment quickly enough or adequately enough under that high pressure, because of course you're capping it at that point, so the CO2 pressure is going to be higher. Maltose may not ferment as readily. You also want to use healthy yeast, and it should be from a low generation, not having been reused too many times or repitched many times, and ensure that it's free of contaminating bacteria, because of course at that point you can't do anything about it once it's in the bottle and sealed. And then for the conditioning, the bottle should be held at a temperature that is high enough to allow for fermentation to occur without impairing their health or leading to more off flavors being produced. And then for cask conditioning, it's recommended to rack the beer in the casks when it's still 2 degrees Plato above the desired finishing gravity, and that will allow continued fermentation to accumulate the carbon dioxide in the beer. And you also still want a yeast cell count of at least 1 million to 3 million cells per milliliter of beer. So lastly, let's look at a few of the other considerations that are important as they may affect yeast growth and fermentation. And so there's been some discussion of temperature already, and temperature is very important to maintain and control in your fermentation. So it has to, the first thing to understand is that it needs to be appropriate for the yeast strain as well as the style of beer that you're looking for, and then to obtain the flavor profile that you're looking for. So nominally, the average for an ale yeast strain would be to hold your fermentation at 68 degrees Fahrenheit. For lager, you're looking at a colder temperature, about 50 degrees Fahrenheit, and these are certainly not the temperatures that one would obtain maximum growth rates of yeast. They would be the maximum growth rate temperatures would be much higher, but the problem would be that you would get at higher temperatures too much off flavor production, especially production of the fusel alcohols, and so these. But just maintaining the temperature correctly can provide a large influence, or problems in temperature can give a large effect on the flavor profile. So for instance, White Labs did a study that found 10 times the amount of acetaldehyde in beer when they increased it from 66 degrees to 75 degrees during fermentation. Another thing that's important to note is that most of the flavor compounds that are of concern are produced in the first 3 days or 72 hours of fermentation, and so it's important to control the temperature, especially during this initial time. If your temperature is too low, then you may not have enough flavor compounds derived, and your beer is a little tasteless, or it may result in your fermentation proceeding too slowly. But then, of course, if it's too high, you can get too much or undesirable flavor compounds, including esters and the acetaldehyde or fusel alcohols. And bear in mind that during their metabolism, yeast themselves will produce heat. So there's a recommendation for a temperature regime to follow during your fermentation, which is to when you have being aware of your optimal fermentation temperature, to try to have the wort below that by 1 to 3 degrees Fahrenheit when you pitch, and then allow the temperature to slowly come up over the first 18 to 36 hours after pitching to the fermentation temperature that you desire, and then hold that until the last about third to quarter of the total fermentation time, and then raise it up a little bit higher. So of course by this time most of the flavor compounds that would be good or bad have been produced, and by raising it after that time slowly in the last 25% of the fermentation period, one can then facilitate getting rid of the diacetyl and off-gassing things like hydrogen sulfide. So the lower temperature at the time of pitch will help ensure that overheating doesn't give you too many esters and fusel alcohols initially, and then especially when you're doing lagers, that higher temperature over the last 2 days or so will help get rid of that hydrogen sulfide. Again, oxygen is really important to ensure, so it's important to make sure that the wort has 8 to 10 parts per million oxygen at the time the yeast are pitched. And the yeast need this for sterol synthesis, as well as to synthesize unsaturated fatty acids. And the unsaturated fatty acids are also important to the structure of the cell membranes. So the yeast will use up that oxygen quickly during the lag in the beginning part of the fermentation phases. And as I said, the oxygen is important for sterols and unsaturated fatty acids. These are both formed from the compound acetyl-CoA. If you don't have enough oxygen or aeration at the beginning, then it's going to hurt the efficiency of fermentation and the eventual attenuation that you can get from your brew. And it could also have effects on future generations of that yeast. It'll impair your ability to reuse them, because they may have their membranes may be compromised. They may not have enough stability to their membranes, which can hurt future uses future pitches from that yeast. So, and then additionally, it can lead to greater amounts of ester if you don't have enough oxygen, which can contribute to your off flavors. A little bit on pitching rates, the amount of yeast to add when you're pitching. If you're not doing this at the optimal rate that you need, it can have an effect on flavor if you're under pitching, because it can lead to a longer lag time for the yeast to catch up, ultimately leading to slower fermentation. It could also give a chance for bacteria or wild yeast to grow more if the fermentation from your desired brewer's yeast is not, if it's not robust enough at the first. Some people may try to have a warmer temperature in the lag phase if they don't have enough yeast available to pitch at the adequate number or the recommended concentration. This can provide some risks, such as it can give you greater amounts of acetolactate that will lead to more diacetyl down the road. If you are forced to do this, though, you can try to correct this by warming again at the end of the fermentation phase to help the yeast reabsorb that diacetyl. Okay, but then you can also have negative effects from overpitching, such as perhaps reducing the amount of desirable flavors that you're going for, because the flavors can be good or bad. I mean, without some of those flavors in the yeast, things like esters, and then the beer doesn't have any flavor, and it's tasteless, or it's too tasteless. And then lastly, let's look at some key aspects of nutrition. So yeasts are in need of course, some of these key nutrients, such as the right amounts of sugars. They initially need oxygen and nitrogen, and some vitamins and minerals that are important. And why are some of these important? Well, for malt-based wort, these are all provided, or they should be provided in adequate amounts. Certainly the sugars and nitrogens, sugar and nitrogen, the vitamins and minerals should be present. After you've boiled the wort, you're not going to have enough oxygen, so that needs to be added. And some cases, zinc may be limiting. So for nitrogen, then, why is this important to have? This is primarily needed for amino acids for the yeast. So amino acids are based on nitrogen, and some amino acid, or if amino acids are present from the wort, the yeast could take these in and use them, and then they can get modified to others in the cell to be used in proteins. Some people may feel the need to supplement additional amino acids because free amino acids in the wort are a precursor. They're what the fusel alcohols are derived from. Then they can contribute to greater fusel alcohol production. So that's something to be aware of or wary of. Another possible nitrogen supplement is diaminophosphate, and this may be used if you're using a larger amount or contingent of other grains like rice that would provide less nitrogen than the barley malt. Vitamins are generally provided in adequate amounts in malt-based wort. Of these, biotin is a real critical one, because this is what's called a cofactor for enzymes. So it's kind of a piece that inserts into enzymes that is critical for their function. And it's critical for a number of the enzymes that are involved in the carboxylation, which is when you transfer a carbon dioxide group. And these are important for the metabolism of amino acids, as well as in the metabolisms of carbohydrates and the formation of lipids, or the breakdowns of lipids. So if you do have a deficiency of vitamins for some reason, it could just lead to slower growth or inadequate fermentation. And then vitamins are typically organic in nature. They're based on carbon compounds. Minerals are inorganic, and so usually you think of these as a type of a metal, basically. but they're a form of the metal that's dissolved in the liquid. So some of the important minerals that are needed also as enzyme cofactors or to be able to uptake other substances. So calcium is very important as a mineral, and this is required for flocculation, as I discussed earlier. Usually that's adequate in the water or in coming from the wort, but it can sometimes be added as a means to enhance flocculation. Magnesium as a mineral is important for the production of ATP for energy, and because it's important for the enzymes that allow this. So you can provide supplements of this if there's an indication that your yeast are stressed, and so it can improve their stress response. The one that may be limiting in wort is zinc, and this is an important cofactor for the critical enzyme of alcohol dehydrogenase, obviously key in fermentation. And so zinc should be present at 0.1 to 0.15 milligrams per liter. If it is inadequate, one can provide zinc supplements. And there's pointers on this in the yeast book if you look at page 75. So for this, the end of the yeast module, it's just important to remember that the yeast are the lifeblood of brewing. They, of course, make it possible to begin with, but their behavior beyond that can dramatically influence the taste of the beer. It's certainly possible to make beer just by taking a malt extract and adding any kind of brewer's yeast to it and letting it sit there, and over time you're going to have something that is beer, but it may not taste very good. So managing the needs of the yeast, understanding what the yeast are doing, and especially controlling their fermentation behavior is critical to having the consistent quality of beer that you're probably looking for. And it's also important along the way to protect what's going on in the fermentation from unwanted organisms, primarily bacteria such as lactobacillus or pediococcus, or wild yeast strains. Again, unless you're going for something that involves those, but at least a lactobacillus or other yeasts, and then of course you hopefully are careful about how you're managing them. So as a brewer, it's also critical to maintain consistency, that you need to keep good measurements of a lot of the parameters of brewing and maintain control of those: temperature, aeration, time that you're allowing fermentation to occur, specific gravity, performing tests for, if you can, things like diacetyl, some of the other compounds that could be formed depending on the size of your operation. So even for the home brewer, though, it's important to keep a good log of all these parameters, and that will help you make adjustments to improve the quality of your beer, or at least stick to them if you have something that's really great. So I'd also recommend additional reading. Of course, I've talked a lot about the book Yeast. You could consider that kind of a textbook for this part of the course of the program. But I've also made available on the website additional pieces of information. One of them is a review called The Microbiology of Malting and Brewing that appeared in the journal Microbiology and Molecular Biology Reviews. And then another review article, Yeast, the Soul of a Beer's Aroma, a review of flavor-active esters and higher alcohols. And that was found in the journal, or it comes from the journal Applied Microbiology and Biotechnology. So thanks for sitting with me on this, and I'll have available additional information about the exams or quizzes for this part of the module. So I hope you've learned a lot from this component, and thank you for your interest in this course.